Okay, textbook page 242. Change in momentum during an impact. By using this formula, net force is equal to change in momentum over the time. If the impact time is the same, larger change in momentum, of course, the net force should be larger. Then look at this example. On the same impact time, okay, you put an object on the ground. Finally, this one will be 0. Then what happened? The change in momentum will be the velocity just before the impact. Okay, it means that just touch the ground. Will be like that. Finally, stop here. Then the total force should be related to it. On the other case, this ball can rebound backward, okay, but rebound like that cannot reach the same height from the initial position. The velocity of it will be like that. Before the impact, just touch the ground, will be negative mv log. After the impact, leave the ground, the momentum will be 0.5 v log. After the calculation, the force, the average force, should be 1.5 times than before. If this one can reach the original position of it, it means that having any energy loss after the calculation will be 2 times of the original forces. Then look at this. Lying at rest. Lying at rest, it means that you just only put a basketball on the ground. Then the reaction force should be in upward direction to balance the downward direction force, mg, should be equal. But during the impact, R should be greater than mg. But why? Look at this. The net force acting on the ball, we have 2 meanings. The first one is to balance the weight, and also one more component of it is to rebound it backward. So you should provide greater force. Then you can look at this. Net force should be the upward force and the downward force. In this case, upward force R should be greater than mg. Then the final net force should be in upward direction. This upward direction force, what is the function of it? Is to provide change in momentum to rebound the ball upward in opposite direction. Then in this case, this one we will say that impact force. Okay, provide the impact force on it. Impact force should be related to the change in momentum over the impact time. Now try to look at this one. We will say that vertical problem. All the problem related to the vertical direction, you should pay attention on the mg. Otherwise, you are wrong. Okay, now try to look at this. This one. Okay, go back to this part. Okay, example 4. Okay, example 4. Bouncing basketball. Look at this. This one is a vertical motion question. Pay attention on the weight of it. Look at the question. Just before impact. Just before impact. It means that just touch the ground. The velocity will be 5. After the impact will be 4.5. The impact time gives you is 0.005. Mass given to you, find the average force acting on it. When you look at this, we know that the final velocity v should be negative 4.5 because I let downward positive. After the calculation will be negative 950. Downward positive. Negative means that the applied force will be in upward direction. is negative 985. In examination, some students may think that this one will be the answer. Remember it. This one is a vertical motion question. Pay attention on the weights. In this question, in this part, in this solution, you haven't write down any mg. It means that you are wrong if you think that this one is the final answer. So look at this. Based on the free body diagram, net force should be the difference between upward force and downward force. Downward force is mg, upward force is r. Okay? Then you will think that in the last slide, r minus mg, but this one, why we use mg minus r? Okay? Actually, never mind. Focus on the direction. Okay? Focus on the direction is very important. You will think that which one is positive, which one is negative, put it in it. Then after your calculation, you can find that you should consider mg. Afterwards will be negative 955. This one tells us that we will provide 5 Newton to balance the weight mg. 5 Newton. The other part of force is 950 to provide impact force to stop the ball and also to move it upward in opposite direction. This one will be the impact force. This one tells us that impact force could be quite large compared with the weight if the momentum change is quite large. So this one, final answer should be 955 instead of 950. What if question? How would the net force acting on the ball during the impact change if it sticks to the ground? It means that 黐住地下, okay? Finally, it means that stop it here. Then it means that V is 0. Net force acting on the ball during the impact time, during the impact decreases. But why? Because you need not to push it upward. You just need to stop it. Okay? Then you should provide a smaller force to stop it. You need not to push it upward. Then the net force should be smaller than before. Okay, this one is example 4. Okay, this one. Okay, next one. Force time graph. Okay, force time graph. What happened? You just need to know that the physical quantities, and then you try to draw the graph. The x-axis may be the time, y-axis may be the velocity. Try to understand what is the meaning. Okay, what's going on in this diagram. Y-axis is the velocity. Velocity we have two. One is the initial one, the other one is the final one. Initial one, initial u is smaller one, final v will be greater one. During this motion, we can have a straight line. Look at this VT graph. The slope in VT graph means that the acceleration. Look at this. Change in velocity over the time should be acceleration A. Then next time when you see this diagram, this graph, the slope of it should be acceleration. Okay. Of course, in this case, we assume that the impact force is a constant. Now, if I multiply the y-axis, it means that the velocity by mass, put it m, then you can see that the y-axis will change to momentum time graph. Then A also multiplied by m. ma means that net force. Then the slope of momentum time graph will be the impact force. Okay, and how about this AT graph? Okay, AT graph. We have the VT graph, AT graph. The slope of the VT graph will be A. Initial one, this part without any acceleration, so This part is 0. Afterwards, keep the same final velocity, 0. But during the motion, we have acceleration A. Keep constant A will be this. And then, in the last chapter, we know that AT graph. From the AT graph, we can find out the area under the curve, under the graph. What is it? The height will be A, the width will be the time. AT, it means that change in momentum. This part, please remember it, delta P. AT graph, you can see delta P. No, my mistake. This one is not delta P, just only delta V, change in velocity. But if we multiply them by M, should be delta P. Area will be the delta P. And one more item you should know it will be Ft. Because F is delta P over time, then we can find that new quantity, Ft, should be delta P. You can have this conclusion. Momentum time graph can convert it into force time graph. One of it related to it will be the slope, the other one will be the area. But what is the meaning of delta P and also Ft? Okay, you can look at this one. This one is produced by the data logger using the computer to record the data and then plot it a graph. The y-axis is the force, the x-axis is the time. This part will be the impact time, okay, measured from the 0. And this one is the highest, the maximum impact force. In this actual case, you can see that the impact force should not be the same all the time, should be changing. This one we can say that instantaneous impact force. This one is very difficult to measure it. Instead of we use very accurate device. But in this, we can find out the area under the graph. Area under the graph, under the force time graph, we will say that momentum change. You can can't find out the area under it. This one will be the moment delta P, the momentum change. If this one is a triangle, you can use the triangle formula to do it. If this one is a rectangle, then you can find out the area using the rectangle. Okay, in examination, this one will be related to level 4 questions. Okay.